Okay, in this problem, we will be using related rates. We'll be taking the total derivative, or we'll be using implicit differentiation. So it gives us that a kite is flying 30 feet above the ground at the end of a string. So we're going to start the problem at 0 here. The girl flying the kite lets out the string at a rate of 1 foot per second. So that means that it's moving along the string. We know that. Now, if it's going at a rate of 1 foot per second and it remains 30 feet above the ground, we know that it's remaining there. That means that your derivative with respect to your vertical velocity or rate of change there is going to be 0. Here is labeled. Now, it asks us how fast the horizontal distance from the girl to the point below is increasing when 50 feet of the string is out. So that means that the 50-foot portion of the string out here is going to be this. Would be along the hypotenuse of the problem. Now, in this problem, they gave us that it was 50, and we know that that it ends at 30 here for y, or it stays at 30 across the board here. But you're going to stop it here for your right triangle because we don't know x. They didn't give us that in the problem. If you notice here, and I kind of have it like labeled out here ahead of time, but if you notice here, this is a Pythagorean triple. You got 50 for your longest side and 30. That only means that, of course, it's going to be 40 for x. I'm going to do the work over here, but where you need to start in this problem is you first use the appropriate formula. You draw out your FBD and so on. So we're going to write out Pythagorean's identity. And the steps are kind of worded out over here. I'll make that a little larger so you can see. Now, in this problem, as I was saying, we need to start out with the appropriate formula. You're going to work on your distance side, and you're going to calculate your implicit derivative on this side. So the first thing we need to do is we need to solve for x. I already know that's a triple, but I'm going to show it. We need to solve for x. We do that here by subtracting y on both sides. Then we plug in our values and square them, 50 for the radius, 30 for the vertical distance. And that gives us 2,500 minus 900. We then get 1,600. We square root it, and that's how I got that 40 up here. So for your total differential, really the meat and potatoes of this, you're going to use the power rule. And of course, you're going to be left with your dr dt, your dx dt, dy dt, respectively r prime, x prime, and y prime. We drop the 2. We use implicit differentiation and the chain rule for our derivatives, and we get this. Now, what's going on here? As stated before, your vertical displacement, the speed, respectively, did give us 0 here. So y prime is equal to 0. So we can plug that in, divide our 2's out, and then solve for x prime, what it is that we are looking for in this question. So I did that here. You're dividing through by x. We now know that's 40. So let's plug everything in. So for r, we have 50. For x, we have 40. The zeros, of course, are going to cancel. And then times our 1 foot per second along the string, right? That's that rate of change along the string. So that gives you 5/4 times 1, which approximates or gets you an exact 1.25 feet per second. And that is the answer to this problem. I hope this helps. And reach out if you have any questions or concerns. I'll be more than happy to help you with your studies.